Look up at the night sky, and you are seeing just a microscopic fraction of the Milky Way. Our planet is a negligible speck suspended in a star field that dwarfs our entire history, a reality that makes our isolation statistically improbable. To calculate the odds of finding neighbors, astrophysicists use the Drake equation. This diagram maps out the formula, which acts like a cosmic slot machine. It multiplies the rate of star formation by the fraction of stars with planets and the likelihood of life emerging on those worlds, showing how quickly the probabilities compound. Looking closer at this array, we can isolate one specific variable, the habitable zone. This is the orbital distance where liquid water can exist. Modern astronomical data gives us a staggering estimate for the Milky Way alone. There are roughly 40 billion Earth-like planets sitting right in that temperate Goldilocks zone. With billions of suitable planets orbiting stars much older than our own, the chemical and temporal ingredients for biology are abundant. According to pure statistics, the cosmic stage is fully set and should already be crowded. Life thrives in Earth's harshest environments, from boiling deep-sea hydrothermal vents to the radiation inside active nuclear reactors. Biology is fiercely resilient, meaning it doesn't require a perfect Earth-like paradise to take hold. Which brings us to a conversation at the Los Alamos National Laboratory in 1950. While walking to lunch, physicist Enrico Fermi ran the cosmic probabilities in his head. He recognized that the galaxy should be full of activity and asked his colleagues a highly logical question: where is everybody? This question became the Fermi paradox. This scale illustrates the contradiction at its core. On one side, we have math predicting billions of probable civilizations. On the other, an empty pile representing zero empirical evidence of their existence. If the math is right, but the sky is empty, it leaves us with three possibilities. Humanity is either terrifyingly rare, we are tragically early to the cosmic stage, or we are completely misunderstanding the mechanics of the universe. This absolute absence of a signal implies a barrier, a silent warning that something unseen might be stopping life from making it out of the dark. To find an answer, astronomers scan deep space radio frequencies, hoping to intercept deliberate interstellar broadcasts. In 1977, a radio telescope in Ohio picked up a continuous, high-intensity signal lasting exactly 72 seconds. It was so distinct that the reviewing astronomer wrote "wow" on the printout. We have never detected it again, leaving researchers to wonder if it was a fleeting beacon from a dying civilization. More recently, telescopes have intercepted fast radio bursts, or FRBs. These are violently energetic flashes from distant galaxies that dwarf normal stellar activity and defy simple natural explanations. Astrobiologists theorize that FRBs could be technological signatures. This animated diagram breaks down how a massive alien structure, like a Dyson sphere capturing stellar energy, would alter a star's natural emission lines and potentially produce these extreme bursts as an industrial byproduct. But crossing millions of light-years degrades the data. At these vast distances, it remains impossible to distinguish between natural cosmic violence and an alien megastructure. Because deep space is so chaotic, astronomers are narrowing the search radius to our immediate interstellar neighborhood, looking for direct, tangible planetary evidence. Right next door, we have rocky, potentially wet targets like Kepler 452b, Proxima b, and TRAPPIST-1e, all located within a few dozen light-years of Earth. Because they are close and potentially habitable, these worlds are the prime candidates for where humanity might eventually attempt interstellar colonization, or conversely, where an alien probe might launch from to reach us. Yet, even from the planets in our own backyard, we hear absolutely nothing. This quiet from our closest habitable neighbors forces us to consider that they might be deliberately ignoring us. If an advanced civilization is watching, they might be enforcing the zoo hypothesis, the concept that extraterrestrials are actively isolating Earth to allow for our unhindered natural evolution in a cosmic nature reserve. When stripped of pop culture stigma, recent declassified military data on unidentified anomalous phenomena, or UAPs, provides unexplained empirical observations of objects moving in our atmosphere with physics we do not possess. If a civilization wanted to monitor us quietly, they could use von Neumann probes. This diagram illustrates the concept of these autonomous, self-replicating drones. One probe lands on an asteroid, harvests materials, and builds 2 more, which then build 4 more. This exponential replication could exhaustively map the entire Milky Way in just a few million years. If these automated probes exist, the unexplained phenomena we observe in our atmosphere could logically be the lingering remnants of an ancient surveillance network. There is one final theory, often called the algae versus alumni problem. An alien intelligence might be so vastly different in its biology or communication methods that it registers to our human instruments merely as background noise. This leads to the shadow biosphere theory. Extraterrestrial life might exist right here on Earth, operating on a biological or informational level, like a microscopic ecosystem that we currently lack the tools to detect. So, we pull back from the microscopic dirt beneath our feet, out past the atmosphere, and return to the dark fastness of the Milky Way. Finding neighbors in the shadows, or confirming we are truly alone, will finally tell us exactly what we are: a cosmic rarity or just one of many.